All right, guys, we are at one of my favorite topics um of network security, which is layer two switching. So we're gonna go ahead and dive right in. I want us to speed past this because we've done plenty of labs on this. But if you guys have questions, please feel free to go ahead and ask whatever question that you guys may have. Okay. All right. So this section is on layer two switching, right? First section we're going to talk about is VLANs or um, virtual local area networks. Okay. All right. So long story short, right? VLAN split physical physical interfaces, right? Your physical device, physical switches, FortiGates, what have you, into um, multiple virtual local area networks. Okay. That's the definition of a VLAN, right? And so if you're running, you're running NAT, right? If we have a design to where we're running NAT, we have different VLANs. Each VLAN, right, at its foundation is its own broadcast domain, right? Meaning all devices can talk to each other in that same network, okay? In that same local area network, whether it be virtual or non-virtual, okay? Um, on this one FortiGate, right, or one switch or what have you, you can have multiple VLANs coexist, right? It's all about how you configure it, right? How you want the traffic to roll, but it's a little bit different coming with working with firewalls, right? So here's where you'll have to know um, some particulars about the exam, right? So what we're looking at now, right, is how these packets, right, or these frames, as we're talking about layer two, right, whenever they pass through, right, a layer two device, how we're able to tell which frame belongs to which VLAN, right? So we're looking at an Ethernet frame, right? We're looking at the layer two section. If we do the packet capture, we're looking at the layer two section, right? So we see the destination MAC, we see the source MAC, excellent, right? We see the type, right? We see the data payload, right? That's in the middle, right? And we see the CRC, right? That's making sure, hey, it wasn't manipulated. We're confirming integrity from a security standpoint that this data, right, this frame that got passed through has not been changed in traffic. Okay. Now let's go ahead and go to the tag control info, right? This is where we're going to see and how we're going to be able to identify VLAN tagging, right? And when I say I mean the layer two device that's operating, right? And it goes based off of the 802.1q standard, right? I want you guys to remember 802.1q, right? That standard relates to VLAN tagging, okay? All right, all right. And so any layer two device, right? They can go ahead and add, remove, you know, tags, right, from this frame, but they cannot change them, right? They can't modify it, but they can go ahead and remove them and take them off, right? What would be the purpose of that? Maybe we have traffic going from one VLAN from one switch, right? And we have a trunk between two switches, right? And it's going to the other switch. We need to go ahead and say, all right, we're ripping this off, right? And then we say, oh, we'll go ahead, it's coming through this port. So we're going to tag it with this VLAN. Okay. So plenty of different things, right? The key things you need to know. VLAN tags add a 4-byte extension, right, to an Ethernet frame. Layer two devices can add or remove tags. Okay. Layer three devices, okay, can rewrite tags before routing. Okay. Right. And what I mean by layer three devices, FortiGate, if it's operating in NAT mode, you guys learned about that. It is a layer three device, and then it would be able to rewrite those tags. Any questions? Because it's going to start to get confusing a little bit since now we're getting to the technical stuff. Don, Makivia, you guys good?
Yep.
Okay. All right.
Yep.
All right. So whenever the FortiGate, right, is operating in NAT mode, right, The FortiGate, right, is going to go ahead and operate at layer 3, right? And what it's going to do is my Kivia, right, that configured this FortiGate, she configured a VLAN interface on the firewall, right? So she created a broadcast domain, right, that exists on the firewall, virtual one, right? And so what does that mean, right? So when packets are, traversing, right, her firewall, right, those different VLAN interfaces, right? What her FortiGate can do from a layer 3 standpoint, right? It can go ahead and add tags when it's leaving or egressing, right? The FortiGate, if it's operating at layer 3, right? If it's coming to the FortiGate, what this layer 3 device can do, right? That we spoke about on the last slide. It can go ahead and remove the tags, right? Or it can rewrite it based on if my Kivia went ahead and set up her design to where she needs traffic to go a certain way. Okay, right? And again, that would be all based on a routing decision. Okay. The key thing you need to remember here, because it may slip up whenever you're taking the exam, the FortiGate will not add a VLAN tag on traffic that's coming into the device if it's operating at layer 3. Okay, that is the job of the other device. It's supposed to go ahead, tag that frame when it's passing it up. Then we should be able to read it and say, all right, cool, this is for VLAN 3, the sales VLAN. I know what to do with it now. Does that make sense? Okay, I'll take that as a yes. All right, so let's look at the example here, right? So if we're looking at the example, right? We got this FortiGate, right? It's running in NAT mode, right? And so we have VLAN 100, we have VLAN 200, we have VLAN 300. Okay, so this PC, right? That's in the branch office, right? That's on VLAN 100, right? It sends a frame, right? Because we're talking about layer 2. When we reference layer 2, we are talking about the name for the packet at the time is called a frame, right? So when that host from VLAN 100 sends that frame, right, to a host on VLAN 300, right, here's what's going to happen, right? I'm going to walk you through the path of a packet. Switch A is going to go ahead and receive that frame, right? And it's going to be untagged, right? Because your PC cannot tag, right? Tag frames and say, hey, it's part of this VLAN. Your PC won't be able to do that. Your switch, that's its job to go ahead and tag frames. So it's going to be, right? It's going to come into the switch, but that port that it's connected on, you understand? It is part of VLAN 100. So now that frame that's coming from this host that has a circle around it in VLAN 100, it's now going to be part of VLAN 100, right? So once the switch does that, it says, okay, the destination is a PC in VLAN 300, right? I'm going to go ahead and send it up the trunk that I have between the FortiGate, right? And now it's the FortiGate's job to go ahead and route this frame, right? Or to pass this frame to the destination. So what's going to happen, right? So that FortiGate goes ahead and receives the frame, right? On its VLAN 100 interface, right? Remember, Kivia configured this firewall. So she created 3 VLAN interfaces, okay? So her FortiGate went ahead and received this frame, right? And it's going to say, oh, I have to route this to VLAN 300 because now I can look at the layer 3 section of this frame, right? So now I'm looking at the packet and I say, oh, it's for an IP address in VLAN 300. Excellent. So routing is telling me, send this to my VLAN 300 interface. Okay. So now what the FortiGate is going to do, it is now going to go ahead and tag, right? Tag this frame that originally had VLAN 100 on it. It's going to tag it with VLAN 300. And it's going to say, excellent, I'm going to send it off its merry way, right? And the FortiGate's now going to send it to switch B. Switch B is then going to receive the frame because it's no longer a packet, right? The switch is operating at layer 2. It's not able to look at layer 3. Now switch B is going to see that frame. It's going to say, excellent, I see the destination. It's for VLAN 300 because, of course, between the Fortigate and the broadcast domain of VLAN 300, before it sent it out on its way, it went ahead and did an ARP, did all those other things, found out what the MAC address is. Excellent. Switch B looks it up. He says, I see what this MAC address is. It's this host that's on VLAN 300. Let me send it down. Okay. And that's how VLAN tags operate on, during relay on a network. Does that make sense?
Yep.
Okay. Staying with me? Okay. Cool. All right. So we were talking about, right? We used my Kiva as an example, and she would create that VLAN, right? So let's talk about it, right? So to go ahead and create a VLAN, very simple, right? I don't think we need a lab on this, right? You go ahead and go into GUI, right? You click on create, right? You go in the interface, say create it, right? So you click on interface, right? After you click on create, it says new interface, right? Not so much the name and the alias. I don't worry about that. How do we say that this interface, right, is a VLAN interface? We go ahead and select type, right? We click on the drop-down list and we select VLAN. Then under that, right, it tells us what interface this lives off of. This is very important, right? So you really need to make sure your design is matching up with how you're configuring your Fortigate. So once you match this VLAN up that you're setting up with the correct interface, so once we do that, right, now here comes the very important part. We need to go ahead and identify and mark what is the VLAN ID. Okay, right? And this physical interface, right, is going to be bound, right, to this VLAN, right, and vice versa. Okay, frames sent and received from this, on this interface for this VLAN is going to be VLAN 101. Okay, right? And so all of these are going to be the frames that come in, they're going to be tagged, right? And so let me take a side step, right? You have tagged and untagged, okay? And so a tag is basically frames that pass through a layer 2 broadcast domain that has a VLAN tag on it. Frames, right, that pass through a layer 2 network that don't have a VLAN tag on it, it's untagged, okay? And so traffic that is untagged, right, that frames that are untagged, right, they belong to what they call a native VLAN, right? Meaning a VLAN that's, hey, it's not specific to a specific domain. It's on the default layer 2 broadcast domain, or the native VLAN, okay? One quick thing I want to make sure, right, that I say, right? And so the native VLAN for different vendors, right, is different for each vendor, okay? Fortigate's native VLAN ID is VLAN 0. Cisco native VLAN ID is 1. And this is, I'm talking straight out of the box. You can change it, but out of the box, right? Right? FortiGate is 0. Cisco is 1. VMware, ESXi, it's 0. So it's a lot of differences, okay? Right? So just be made aware of this, okay? All right, let's keep going. Does that make sense?
Yes.
Okay. Awesome. All right, I'm going to go ahead and ask one question, right? So, question 1. Which mode must the FortiGate VDOM be operating in to route traffic between VLANs? Is it A, transparent mode, or is it B, NAT mode?
NAT mode.
B, that mode.
There we go. Okay. All right. So, with that being said, I'm going to pause here. Give me 1 second. Okay. All right, let's go ahead and give me 1 second. 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 All right, let's go ahead and jump in. So, virtual wire pairing, right? Typically we skip over this part, but let me make a quick, an important piece of this, right? Virtual wire pairing, right? It's segmenting the layer 2 network into multiple broadcast domains. Okay. All right. Let's go ahead and jump on in, right? And you'll see pictures of how this looks. I'll go ahead and explain it, right? But VW or virtual wire pairing, right? What this is when you have two physical interfaces, right? Port A and port C, right? And right, they're operating, right? A Fortigate at its core, right? If it's out of the box layer 3, it's each interface is its own broadcast domain. But what if you just need these two physical interfaces, right? To pass traffic, right? Between each other and be part of the same broadcast domain for whatever, the same VLAN for whatever reason, however you want to place it, right? If it needs to be part of the same broadcast domain, right? What you can do to go ahead and combat that, right, is you can go ahead and configure a virtual wire pair. And what this will mean is ports A and C, right, going back to my example, will now be bounded, right? They'll be now linked as one port, as if they're one port, right? Or a small switch, right, between two ports, right? And so traffic that's passing through port A, going through port C, right? It's a part of the same broadcast domain. It's no longer just port A is one broadcast domain and port C is broadcast domain. Okay. Right. And so how it works is all traffic that comes in, right? One port, that'd be port A, is just forwarded to another port, right? So traffic is not going to go through any other port. How that VW pair works, comes in one, goes out the other. That's it, right? And what this does, right, it prevents layer 2 issues like broadcast storms or MAC flapping, because MAC flapping is a damn pain. Right, you can have more than 4, 5, 6 VW pairs on a FortiGate. It all depends on the hardware that you have available to you. Okay, so just keep that in mind, right? So let's look at this diagram, right? And let's talk about virtual wire pair, right? We know that transparent mode, right, for FortiGate means that the FortiGate is running at layer 2. Okay, right? So for this example, right, this is the FortiGate that Donovan set up, right? Running in transparent mode, right? And he has 4 ports operating, right? Each connected to different physical locations, right? And so, but traffic is not allowed to flow between all four physical interfaces, right? So what Don did, right, being the architect that he is, right, he went ahead and implemented the virtual wire pair. And what this means is that 2 ports are bounded to each other and they're not going to go through any other port, right? So port 3 is bounded to WAN 1. So traffic that comes into port 3 will only go to WAN 1. And traffic that comes into WAN 1 is only going to go to port 3 because they're bounded by that virtual wire pair. Same thing for port 1 and port 2, right? If it comes in port 1, it can only go out port 2 and vice versa. Okay? That makes sense?
Yep.
Okay. All right, so this is a little bit more complex, right? So let's talk about VW pairing in NAT mode, right? So Antoine, right, he went ahead and set this up, him being the senior network engineer. He went ahead and set this up, right, for his complex enterprise network, right? And so he has it running in NAT mode, so it's running in layer 3, right? So he has packets coming in, WAN 1, in the internal interface that's going back and forth, right? Right, and they're routed, right, using layer 3, okay? Right, and so you see they have different IP addresses, so they're in different broadcast domains, okay? Now let's sidestep, right, and let's talk about WAN 2 and the DMZ interface. I don't see IP addresses on there, right? And the reason why there's no IP addresses on there is because Twan configured them as a VW pair, a virtual wire pair, right? They don't need IP addresses. Basically, what's going to happen, right, is that WAN2 and the DMZ are all part of the same broadcast domain. So that server that you see that's sitting all right there, from its standpoint, it's connected directly to the router that's hanging off of WAN2. Okay? It's on that same subnet for router 2 versus what's going on between WAN 1 and the internal. Does that make sense of how virtual wire pairing works?
Can you explain that one more time? So just to reconfirm, you said that the DMZ is
So
connected directly to the router?
yeah. So don't get hung up on DMZ. I don't want you to get hung up there. DMZ and WAN 2 are just physical interfaces.
Right.
And they're just what, for this example, what Antoine called them. I want you to focus that these interfaces don't have IP addresses on them on a Fortigate that's running in layer 3 because Twan configured them to be a virtual wire pair. The fundamental rule of a virtual wire pair is that they bound 2 ports together, right, to be part of the same broadcast domain. Okay? And the exception is traffic can only pass through those 2 ports. It can't go to anywhere else. So Twan went ahead and configured his web server, right? Because it has to be a web server, right? That is, services his customers or what have you of his organization, right? That needs to be available to the outside, right? So, he has a direct connection, right? Going through the switch, right? Going through the DMZ interface, going through WAN2 to the router. He has a direct connection to the router. He can ping the router, right? Because it's on the same network. Why? Because we have a virtual wire pair between the two. Okay? And again, virtual wire pair is a layer 2 technology. Okay? As soon as he configured these interfaces to be a virtual wire pair, it went from being layer 3 interfaces to being layer 2 interfaces. He can never assign an IP address to them. Does that make sense?
So like the virtual wire pair could never get an IP address.
Yes.
Okay. Yeah, that makes sense.
And that's configured in the CLI of the firewall, or how's that configured?
So you can configure it in the CLI, but it's mostly done within the GUI.
Okay.
Okay? Make sense, guys?
Yes.
All right. Let's keep rolling. All right. So, great question, Mike. You went ahead and spoke it up. This is how you configure it, right? When you go ahead and say you go to network, you go to interfaces, and you click on create new, and you click on virtual wire pair, you have to select 2 interfaces, no more, no less. Okay. After you go ahead and select your 2 interfaces, what'll happen is virtual wire pairs have policies, right? They need to go ahead and configure as far as traffic that is crossing the virtual wire pair. Okay, and that's going to be on the next slide, right? The wildcard VLAN setting, right? And this is very important because it confuses a lot of people. That setting specifies how the policies, right, that you set up are applied to different VLANs whose traffic flows between the pairs, right? Okay, so what does that mean? If Antoine said, all right, I'm going to go ahead and enable wildcard VLAN, right? What's going to happen is the VW pair, right? The policies are going to be applied equally to the physical interfaces and VLANs, right? So they're going to be applied to both interfaces, not just one direction. It's going to apply to all, right? All VLANs that are passing through and what have you. If he disables it, right? He disabled wildcard VLAN. The virtual wire pair policies are applied only to the physical interfaces, right? And that's it. It's only applied to the interface. So now you would select actual interfaces that you want these policies to apply, right? But here's the thing. If you disable wildcard VLAN, if you have traffic that's passing through with the VLAN tag, it's denied. Because it's not going to be able to read VLANs.
So with the wildcard, just the wildcard VLAN disable, it's not going to be able to read VLANs at all.
Yep, it's not going to be able to read VLAN tags.
Okay.
Make sense?
Yeah.
Okay. All right. So here's the nitty and gritty, right? So here's the virtual wire pair policies, right? Because as soon as you go ahead and configure interface, VW wire pair policy is going to pop up, right? And you go to policy and objects, right? Firewall virtual wire pair policy, right? And you'll be able to go ahead and configure, right? Right? And you can go ahead, and the beauty of it, right? If Twan has multiple virtual wire pairs, you can go ahead and set it up, right? You can go ahead and say, hey, just one virtual wire pair, multiple virtual wire pair, right? You can make this up, make it as much as it benefits your environment, right? You just need to make sure that you design it properly, right? So traffic that is passing through the right way. Okay. All right. Okay, and we'll go over this a little bit tomorrow. Okay. Let's go ahead and keep going. And we went ahead and finished VW pairing. So let's go ahead, and I think my Kivia left us for a little bit. With that being said, I'm going to ask the last two questions, and then we'll go ahead and end it for today. Okay, so question one, right? Which configuration setting must be enabled to allow VLAN tag traffic through a virtual wire pair? Is it A, transparent bridging, or is it B, wildcard VLAN?
B,
A.
wildcard VLAN.
Correct.
Oh, it's B?
Yep.
Oh,
So I don't know if you saw it, right? If we disable, right, wildcard VLAN, policies apply only to the physical interfaces, not to
you said
VLANs.
disable, not enable. Okay.
Okay. All right. Let's keep going. All right. Question two. How is traffic handled in a virtual wire pair? Is it A, incoming traffic to one interface is always forwarded out the other interface, or is it B, traffic is forwarded based on the destination MAC address?
Is it B?
B. Wait, say the question one more time, please.
Okay. How is traffic handled in a virtual wire pair? Incoming traffic to one interface is always forwarded out through the other interface, or is it B, traffic is forwarded based on the destination MAC address?
Oh, it's A, because they only
Okay.
communicate with each other. Yeah, it's A.
There we go. Okay. All right, guys. That is it for tonight. We'll go ahead and start back tomorrow morning, okay? I mean tomorrow morning, tomorrow night, all right?
Thanks, guys.
Thanks.
All right, guys. Later.